The first creational design pattern that we'll discuss in the context of the JavaScript programming language is the constructor pattern. The constructor pattern allows us to construct or create objects that meet our specific use case. So, what exactly is a constructor from where this pattern gets this name? Well, a constructor is a special method to initialize a newly created object once memory has been allocated for it. In any programming language which allows the creation of objects, the first thing that is done when you create an object is that memory is allocated on your local machine to hold the contents of this object. Once memory is allocated, the properties of your object have to be initialized, and this is done typically in a constructor. If you were working in an object oriented programming language such as Java, constructors would be associated with classes. But everything in JavaScript is an object, including functions. So, constructors that we refer to here are object constructors. Objects here are actual instances that take up memory in your system and have a tangible existence. In JavaScript, you can have your object constructors create specific types of objects and initialize the member properties and methods of those objects. Objects typically refer to entities within your system: employees, students, the school, a department, the organization. All of these are examples of objects that you might construct. The JavaScript programming language allows for one-off instantiation of objects. Objects that have exactly one instance, you create these objects kind of in a one-off manner and then use the objects and its properties. Objects which are created in this way use basic constructors where you create a simple object and assign properties and methods to that object. Basic constructors offer the simplest object creation mechanism in JavaScript. But JavaScript also allows you to templatize the construction of objects that are similar to one another. For example, objects that you use to represent different employees in an organization will have very similar characteristics. In order to construct such objects, you'll use prototypal constructors. Prototypal constructors allow multiple objects to share methods instead of every object having its own reference to every method. When you use prototypal constructors, these shared methods are part of the object's prototype property. So, what is this prototype object that we reference so often in JavaScript? Every function in JavaScript has a special property called the prototype property. In fact, every object in JavaScript has this property, and functions in JavaScript are just objects. Generally, when we refer to the prototype object, what we are referring to is the prototype property of a function. This prototype property is generally a reference to an object, and methods and properties can be assigned to this prototype object of any function. These methods and properties that are assigned to a function object's prototype are shared across all objects that are created using this function. Now, if you think of functions, they are just a reusable bit of code. Functions happen to be objects in JavaScript. There is no reason for us to create a new function object for every object that we instantiate, for every method that it has. It's good practice to share these methods across all objects created using a function, and we do this using this prototype property. Methods and properties on the prototype are used to define object inheritance in JavaScript, which is why inheritance in JavaScript is referred to as prototypal inheritance. Methods and properties defined on a function's prototype are available in all objects created using that function are inherited by all objects created using that function. This is prototypal inheritance. Now, you might have heard that JavaScript is a classless programming language. It does not understand the concept of classes. Well, but what about ES6 classes? What about the class keyword that we can use to define classes using the ECMAScript version 6 of the JavaScript language? Here we'll understand what ES6 classes mean and how they relate to functions in JavaScript. Now we know that functions in JavaScript are essentially objects, and prototype objects on functions help set up object inheritance. Now, over the course of several years, there were many small upgrades made to JavaScript, but back in 2015, there was an important upgrade, which was ES6. This is an enhancement to the JavaScript language released in 2015 that makes large scale development in JavaScript easier. ES stands for ECMAScript, which you can think of as the official term for the JavaScript language. Now, an important feature that ES6 added was the ability to define classes in JavaScript using the class keyword. But though the structure of a JavaScript class looks very similar to the structure of a Java class, if you're used to Java as a programming language, the way it works is very different. A JavaScript class is essentially just a function object. The class keyword that was introduced by ES6 is just syntactic sugar over JavaScript functions. So, when I speak of instantiating classes in JavaScript, essentially what we'll be creating is function objects. These function objects we'll create using the template that the class has defined for us, but there are no new classes in ES6. The class keyword is just syntactic sugar over function objects. We'll be writing all of the code here in this design patterns course using the Sublime text editor. This is an editor that is freely available. You can, of course, use any text editor of your choice, and that's completely okay. If you're interested in using Sublime, here is the URL where you can download and install Sublime either for your Windows machine or your Mac OS machine. Sublime is a great text editor. It's simple, easy to use, and it has great syntax highlighting. Before I launch into the first design pattern here, the constructor pattern, I'll give you a quick overview of the folder structure where my code is set up so you know how the code is organized. Observe that on the left, I have a top level folder called design patterns, and the different design patterns will be in subfolders. You can see that under the top level design patterns folder, I have another subfolder called the constructor pattern. And this is the subfolder where we'll be working with the HTML and JS files that will implement the constructor pattern. Now, before we get started with the actual JS code for the constructor pattern, here is the HTML file which will invoke our JavaScript code. For most of the patterns that we'll discuss, you'll find that the HTML file is very straightforward. It will simply contain a header with a title saying it's the constructor pattern. We have an H2 header which says constructor pattern, and we have a script source tag that points to constructor pattern.js. And constructor pattern.js is where all of the interesting stuff will lie. For a few of the design patterns, the HTML code that we display within the browser will be more involved. For the most part, it will be simple like what you see here on screen. So I'm going to switch over to the tab for the JS file here, constructor pattern.js, and let's get started with coding. So, what exactly is a constructor? If you come from an object oriented programming background, let's say you've coded in Java before or even in Python, which does have classes, inheritance, and objects, a constructor is basically a special method that you use to initialize an object once memory has been allocated for that object when the object is first created. Now, JavaScript is not really an object oriented programming language, it's more of a functional programming language where functions are essentially objects. The kind of constructors that we're really interested in JavaScript are object constructors. And we have a pattern around this because there are many different ways in which you can set up objects in JavaScript and assign properties and methods that are associated with objects. And in this bit of code that we are going to write here, we'll explore the different ways. The easiest way to instantiate an object in JavaScript is simply to use the curly braces. This is the object literal notation. Here I've instantiated an object which I've assigned to the variable student. At this point in time, the student object is completely empty. It contains absolutely no properties and no methods. I'm going to write out a console.log statement to print the contents of this student object to the console messages of my browser window. All browsers, Chrome is what we'll be using in this course, come equipped with developer tools using which you can display console messages. It's extremely useful for debugging. I'm going to switch over to my terminal window here, and in my current working directory, I'm going to bring up the HTTP server by running HTTP server followed by a dot. I have the server running on port 8080. I'm going to copy over this URL and paste this into my browser window. All this will do is list out the contents of my current working directory, and here within a folder called project, I have all the code for my design patterns course. So I'm going to head into project, and inside here I have this design patterns, that is my top level folder. Click through and go to the design patterns folder. This is the top level directory for this learning path. And under this directory will be all of the subfolders for the different design patterns that we'll explore. I'm going to click through to the only subfolder here at this point in time, the constructor pattern. All of our patterns will include an HTML file and a corresponding JS file which contains the code. I'm going to click through to the HTML file, which will then run the code that is present in the JS file. The code in our JavaScript file has been executed, but you can't see anything because we don't have Chrome Developer Tools open. We've opened up this web page on the Chrome browser, so we need to use Chrome Developer Tools. In order to bring up Chrome Developer Tools, if you're on a Windows machine, run the shortcut Windows plus Shift plus J and Developer Tools will open up. If you happen to be on a Mac OS machine, hit Command Option J to open up Chrome Developer Tools. Instead of using shortcuts, if you prefer to use the mouse instead, all you have to do is hit right click within this browser window and choose the inspect option from the right click menu that pops up. And this will open up Chrome Developer Tools, and you can proceed with this demo as we are going to do. Notice that Chrome Developer Tools opens up here and the empty student object is present as a part of our console log messages. We can see here that the console tab is the one that is selected and the console messages are printed within the console tab. I'm going to expand this object that has been displayed here in order to view the contents of this empty object, and you can see that this object contains nothing. The proto property that you see here contains whatever was present in the base object used to construct this object. All objects that you create in JavaScript, including function objects, objects that you create using the object literal notation, which is what we did, inherit from the object base class. This is object with a capital O. The proto property in any JavaScript object points to the object that was used to create the current object. This proto property allows us to view the inheritance chain for our JavaScript objects. Are all of the functions that have been inherited from the prototype property of the base object class. Any object in JavaScript has this prototype property, and this prototype property is what we use for object inheritance in JavaScript. The object base class is the base class from which all objects inherit in JavaScript, and it contains a bunch of methods and properties that you see here on screen. It has its own constructor, it has methods such as hasOwn property, is prototype of, and so on. If you expand the constructor method here, this is the constructor of the object base class because that is what was used to construct this empty student object. You can expand the individual methods in order to explore more details. Now that we've oriented ourselves with JavaScript objects, let's head back to the Sublime text code editor. And I'm now going to assign some properties to this object. And this assignment can be done in a variety of ways. You can use the dot notation to assign properties to objects. Student.name is equal to Alice. The name property will now contain the value Alice. Or you can use the square bracket notation. Student, and in square brackets and within quotes, we specify the university property and the student studies at amazing university. And once again, I've used the dot notation here. Student.gpa is equal to 3.8. Once you've created an object, you can assign properties to this object using the dot notation or the square bracket notation. Let's print out the student object now that it has a few properties, once again using console.log. Now, when I head back to my Chrome browser window, I need to hit refresh in order to re-execute my updated JavaScript code. But observe that the student object is still empty. I need to enable a specific setting within my Chrome Developer Tools in order to ensure that I get the updated JavaScript file on each refresh. This is to prevent Chrome from caching the JavaScript and HTML content of my files. Click on the three-dot menu and head over to the settings option here. This will open up some settings for your Chrome developer tools and your Chrome browser window. I'm going to scroll down here right to the middle of the screen where I have an option which says disable cache when dev tools is open. Now this means that whenever Chrome developer tools is open, our Chrome browser will not cache our JavaScript and HTML files, which means any updates that we make to our JS file will be immediately visible. If you're developing JavaScript and working with Chrome, this is an extremely useful setting that you need to know about. I'm going to hit refresh on this constructor pattern page once again. And here is my student object now with properties assigned. You can see that the three properties that we are assigned are visible here. Name is equal to Alice, university is amazing university, and the GPA is 3.8. Now, if you expand the prototype property of this object, you'll find that the prototype property remains the same as before. We haven't added anything to this object's prototype. We've added all of our properties, name, university, and GPA directly to the object itself. This is pretty significant as we shall see in just a bit. You can close out the contents of this object and let's switch back to our Sublime text code editor and add in a function to be a part of this object. Hopefully, you're probably already aware that functions are just objects in JavaScript. So the student.printDetails property is a function object. It contains a reference to a function. We'll keep this function extremely simple. You can see that it just contains a bunch of console log messages. The first message simply says print details, that is the function that we've called. The second console.log message prints out the other properties that we've assigned to this project. This.name, this.university, and this GPA with the square bracket notation. Within any JavaScript object, this is a special reference to the current object, allowing us to access the current object's name, university, and GPA information. Now, one thing I need to draw your attention to about this print details function object, I've assigned it directly to the student object that we had created earlier using the dot notation. This is important, so keep this in mind. Now that I have a function property assigned to this object, I'm going to print out this updated object to the console log messages as well. And let's switch over and hit refresh on our Chrome browser. And here is our student object along with function properties. If you expand this object, you can see that the print details as a function is now part of the student object. Notice that the print details function is a property of the object itself. And if you expand this print details function, you can see that print details has a prototype property by itself. The function itself is an object, as is true in JavaScript. Once again, I'd like to emphasize here that this print details function is a part of the object itself and not the object's prototype. So if you expand the proto property for this object, you can see that the functions defined here are the same functions that this object has inherited from the base object class. Now let's switch back to our Sublime text code editor and invoke this print details function on the student object, student.printDetails. And if you hit refresh on your Chrome browser, you can see that the details of the student object are now printed out to screen. This.name prints out Alice, this.university prints out amazing university, and we've printed out the GPA of the student by accessing the GPA property using the square bracket notation. You can see here that the dot notation and the square bracket notation to access the properties of an object are completely interchangeable. In the previous videos, we saw one simple way to create or construct an object in JavaScript. Here we'll take a look at a different way or a different technique that you can use. So go ahead and select all of the code that you've written so far and hit delete. We'll start afresh in the same file, constructorpattern.js. In order to construct a new JavaScript object, it's also possible for you to use the object.create function. Object is the base class for all objects. Object.create allows us to create a new object. You can see that object.create here takes in an input argument, and the value that I have specified for this input argument in this example is object.prototype. So what exactly is going on here? So we call object.create to create a new object, and the input argument here is some other object. The newly created object, which in our example happens to be another student, will use the properties of the object that has been passed in to the object.create function as the prototype for another student. The line of code that we have here means that all of the properties of object.prototype will become part of the prototype of the newly created object. The newly created object is the one that we assign to the another student variable. This basically causes another student object to inherit all of the properties present in the base object's prototype. Every object in JavaScript, including function objects, have a prototype property. And this prototype property is an object that contains other properties and methods. The base object in JavaScript, that is, object with a capital O, also has a prototype. And there are functions and properties which are part of the prototype property of the base object, which is what we'll use to create this new another student object. Once this new object has been created, we can once again use the dot notation or the square bracket notation to assign properties to this new object. Another student dot name is equal to James. The university that James goes to is Intelligent University, and another student square brackets GPA is equal to 3.4. These lines of code successfully assign the name university and GPA property to our newly created student. I'm now going to assign a function object to the student as well. Exactly as we did in our earlier demo, I've assigned another student.print details to a function. Within the function, we'll just print out the details of the current student. This dot name to print out the name, this square brackets university to print out the university, and this dot GPA to print out the GPA. Observe that I use the dot notation to access properties and the square brackets notation interchangeably, and this is totally valid. I'll now use a console.log message in order to allow us to view the contents of this another student object. Make sure you save this file and let's switch over to our Chrome browser window, and I'm going to right click and clear the current console messages. Go ahead and hit refresh in order to view the changes that we've made to our JavaScript file. Here we use the object.create function in order to create this another student object. Expand the contents of this object and you can see that the name, GPA, university, and print details property are all on the object itself. You can see from the structure here that print details happens to be a function object. The function object has its own prototype as we've already seen earlier. Now I'm going to expand the prototype of this current object and you can see that it has inherited all of the functions present in the base object class in JavaScript. When we use the object.create function to construct this object, we had passed in object.prototype, indicating that this another student object that we create should have all of the properties present in object.prototype. And this is exactly what you see here in the proto property of our newly created object, the functions that have been inherited from object.prototype. Now let's switch back to our Sublime text code editor and I'm going to invoke the print details function on another student. We can now switch back to Chrome and satisfy ourselves that student details will be printed. Hit refresh and you can see that we have James here who belongs to Intelligent University and has a GPA of 3.4. The this reference that we use within another student.print details refers to the current instance of the object. Let's go back to our Sublime text code editor and we'll see yet another way that you can use to construct an object in JavaScript. Select all of the code that you've written so far and hit delete, we'll start afresh. Another technique that you can use to construct a JavaScript object is to use the new keyword. New object followed by parenthesis will construct a new object and assign it to the yet another student variable. This will be a completely empty object to start off with unless you specify properties within the parenthesis, which we haven't done so far. And this newly created object will also inherit the methods from the base object's prototype. Let's go ahead and assign a few properties to this newly created object. Once again, we'll use the dot notation to assign properties. You can use the square bracket notation as well. Student.name is Nancy, yet another student.university is Pinnacle University, yet another student.gpa is 3.3. Once again, I'll assign a function property to this object. Yet another student.print details is a function which will print out this.name, this.university, and this.gpa. I'll now go ahead and console.log this object within my console messages and switch over to Chrome and hit refresh. And here you can see yet another student. If you expand this yet another student object, you'll see that all of the properties that we assigned GPA, name, university, as well as print details are on the object itself, not on its prototype. And you can see that print details here is a function object. Now, if you take a look at this proto property, the proto property, as you know, points to the object that was used as a prototype to construct this object, yet another student, which is the base object in JavaScript. And in order to satisfy ourselves that this object works in exactly the same way as the objects that we've created previously, I'm going to invoke the print details function on this object. Let's switch over to Chrome and hit refresh. And here are the details of the student Nancy printed out to screen. So far, all of the JavaScript objects that we've created have been one-offs, in that we use the type literal notation object.create or new object to create a single object. We haven't really set up a template for object creation, and that's exactly what we'll do next. Typically, in the real world, when you're constructing objects, you might want to create several objects which follow the same template. In object oriented programming, this is typically a class. In a functional programming language such as JavaScript, you can use functions to define function objects that can be parameterized and used to create other objects. There are no real class constructors in JavaScript. Even ES6 classes are just syntactic sugar over special functions that serve as constructors. In order to create objects that follow the same template, we'll set up special functions that serve as object constructors. These special functions can then be used to create objects by invoking these functions along with the new keyword, and that's exactly what we'll do now. This function named student here is a special function that can be used to construct an object. You can see that this student function takes in input arguments, the name of the student as well as the university at which the student studies. The values that we pass into these input arguments will be used to initialize the objects that we create. Within the function body, we initialize the name and university properties for the current object using the input arguments passed in. This dot name is equal to name, this dot university is equal to university. Now, in order to define functions that are properties of this object, you can define your function within the student function body itself. This dot print details is a function which simply prints out the name, university, and GPA of the current object instance. Remember, this references the current object instance. When you define a function within this function constructor body, this function object will be recreated for every object that you instantiate using this special function constructor. And if you think about it, this is actually wasteful because you'll have a new separate function object for each object that you instantiate. You don't really need separate function objects. You should be able to reuse the same function instance for all the objects that you create using the student function. We'll discuss that in more detail in just a bit. I'm now going to create a new student object using the special function that we set up earlier as a constructor. This requires the use of the new keyword. New student will create a new student object. The name of the student is Nora and she studies at Pinnacle University. These are the input arguments that we pass in to construct this student object. I'm going to print out the student object to my console log messages and let's take a look. Hit refresh on your Chrome browser and let's take a look at this new object that we've constructed using a function. Go ahead and expand the student object and you'll be able to see the properties that have been assigned. The name property is assigned to Nora, university property has the value Pinnacle University, and print details, which is a property on the student object, is a function. The fact that print details is a property on the student object that was constructed means that a new print details function object will be created for every student object that we create. Let's close out this print details function object and let's take a look at the proto for this student object that we constructed using a special function. Observe that the constructor for this object is the student function that we had defined. Student that takes in the name and the university of a student and creates a new object, constructs a new object. Let's switch back to our code editor here and I'm going to invoke the print details function on the student1 object. Print details will print out the name, university and the GPA for a student, but when we hit refresh on the Chrome browser, you can see that no GPA property has been assigned. That's why GPA is undefined. I'll switch back to my code editor here and assign the GPA property for my student1 object. Student1.gpa is equal to 3.7 and let's now print out the student1 object to ensure that this property is now available. Hit refresh on your Chrome browser and you can see that student1 now has a valid value for the GPA property. You can expand the student object and you can see that GPA is set to 3.7. Now if we switch back to our editor and invoke student1.print details, all of the details of the student including the GPA will be printed out to screen. You can see that the name is Nora, university is Pinnacle University and GPA is 3.7. Now, I'd mentioned this fact earlier that the print details function is a property of the student object, which means for every student object that you create and construct, print details will be a new function object that will be created. So, if you have 1,000 student objects, you'll have 1,000 print details function objects associated with those students. This is a complete waste and this can severely affect the performance of your web application. What we really want is for all student objects to share the same function object. This is what is efficient, this is what makes sense. In order to be able to do this, you need to declare and define your functions on the prototype of the student object, student.prototype. Methods that are defined on the prototype of our constructor function will be shared across all objects constructed or created using that constructor function. What does that mean? Well, if you have a method such as the show details method here, you should define that method on student.prototype, not within the function body of our constructor. All functions come with this prototype object, as do all objects in JavaScript. So you can simply say student.prototype.showDetails and define your function here. Show details again prints out to screen the name, the university, and the GPA of the current instance. This reference here within show details refer to the current instance of the object on which the function is being invoked. Now that show details has been defined on this student function, we can invoke the show details function on the object that we had constructed earlier before this function was defined. Student1.showDetails will show us the details of the student. Hit refresh and here at the bottom you can see the results of show details. Show details was invoked on student 1 with name Nora, university is Pinnacle University, GPA is 3.7. Let's head back and construct yet another student object using the student function constructor. We use the new keyword with the student function as we did before, and that becomes a constructor of the student object. Damien is a student, he studies at Science University and has a GPA of 3.2. Let's print out the contents of this student2 object, and you can see this here at the bottom, student2. When you expand this object, you can see the details of this student. You can see that Damien has a GPA of 3.2 and studies at Science University. You can also see that the print details function is available as a property on the student object. But where is the show details function? Well, remember that show details was declared on the prototype of our student function constructor, which means show details is a part of the proto property of this student object. You can see the show details function under the proto property. Methods that are defined on the prototype of your function constructor become a part of the proto property of the objects that you create using that constructor. Let's now invoke student2.print details and make sure that this function is correctly invoked. If you hit refresh, you can see the results of print details have been printed out to screen. It's also possible for you to invoke the show details function declared on the student function's prototype. Student2.showDetails Hit refresh and the details of Damien are printed out to screen using show details. Now, we discussed earlier that JavaScript doesn't really have the concept of classes, but we can use special functions as constructors along with the new keyword. And that's what we studied in the previous demo. However, it's kind of tedious to use these functions as constructors. We have to remember to declare methods on the function's prototype and so on. Now, this was something that the developers of the JavaScript programming language realized, and they took steps to mitigate this. ES6 or ECMAScript version 6 is the latest version of the JavaScript programming language, which was released in 2015. ECMAScript is the standardized name for the JavaScript programming language, and ES6 is the version released in 2015, which made major enhancements to JavaScript. And one of the most important features that ES6 added to JavaScript was introducing the concept of classes. These classes are not really real classes, but they allow you to declare function objects using a familiar class syntax. And this ES6 class syntax is exactly what we'll study next. I'll now go ahead and select all of the code that we've written so far in this file and hit delete. And we'll start afresh and take a look at ES6 classes. We've defined a new class here using the class keyword, and the name of the class is student class. This is an ES6 class. You should know though that these are not classes in the real sense. These classes are not the same as the classes that we'd use in an object oriented programming language such as Java. These classes are just syntactic sugar over objects that we create using special function constructors. So the nature of JavaScript hasn't changed. The use of the class keyword is to just make clear to users that you can construct objects using this class. If you want to assign and initialize properties for the objects that you construct using this class, you specify a special constructor method within the class. The name of the method is constructor and it takes in input arguments. Here, the input arguments happen to be name, university, and GPA, and we assign the values passed in to this.name, this.university, and this.gpa. You can also define functions within this constructor method. This.printDetails is a function which prints out the details of the current object, the name, university, and GPA. This student class definition, along with the constructor where you assign values for properties and where we've also defined a function, is the exact equivalent of the function student that we had set up earlier. So what we've achieved using the class keyword and the constructor method within the class is exactly the same as what we achieved when we defined the special function that we used earlier to construct student objects. When you define a function within a constructor, a new function object will be created for every student object that you construct. Once again, this is inefficient and not very performant. The print details function will not be on the prototype of the student class. Instead, a print details function object will be created for every student object that you construct. If you want a function to be defined on the prototype of the student class, which is exactly what you would want in order to ensure that the same function object is referenced by all student objects, you'll define it as you see here on screen. Show details will be on the prototype of the student class. The show details function here is not within the constructor. Instead, it is within the student class itself. Let's now go ahead and construct a student object using this ES6 class. You simply use the new keyword, specify the name of the class, that is student class, and pass in the input arguments. Robert, studying at Professional University with a GPA of 3.9. Now this object has been constructed and assigned to the variable student underscore 10. Let's log it out to the console. Let's switch over to the Chrome browser and hit refresh, and you can see the contents of the student 10 object here. You can see that name is Robert, the university is Professional University, and the GPA is 3.9. Note that the print details function that we had defined in the constructor of the student class is now a property of the object student 10. It's not on the prototype, it's a separate function object that is instantiated for each student object that we create. On the other hand, the show details function, which is not defined in the constructor but instead defined within the student class itself, becomes part of the prototype of this object, which means the same function is shared across all student objects, which is what we want. So we now know the different ways that we can construct a JavaScript object and what the trade offs are. Now, all that's left for us is to invoke student.print details and student.show details to make sure that these work correctly. Hit refresh, and you can see that the details of the student Robert have been successfully printed out to screen using print details as well as show details. In this video, we'll discuss two design patterns that are closely related to one another: the factory method pattern and the abstract factory pattern. We'll first start off with a discussion of the factory method pattern that allows us to create objects without working directly with the object's constructor. Now, the factory method provides a generic interface for creating objects where the clients simply specify the kind of object to be created. They use this generic interface, they don't know what object will be constructed, but they know the kind of object that they want. Based on the object type specified, the interface behind the scenes will take care of constructing the right object and returning it for clients to use. Thus, a single interface can create multiple types of objects, and all of the complexity of object creation is hidden away from clients. The factory method is generally used when there is a class or object inheritance hierarchy involved. This involves several derived classes that are concrete representations of a base class. The base class provides common characteristics. There are derived classes which offer specific characteristics based on the type of derived class. Using the factory method in order to create instances of the derived class types is especially useful when the derived classes are fairly complex and may require lots of configuration. You don't want to expose the configuration of these derived classes to your clients. The idea of exposing a factory method, which is essentially the interface that you use to create the objects that you need, is to allow for this creation code to be extended. The factory pattern follows the open close principle in that this pattern is extendable. New objects can be created using the same factory without modifying the code for that factory. You'll choose to use the factory method to manage object creation when objects are different but with similar characteristics. So you have different objects but maybe belonging to the same family. Objects may all be vehicles but different kinds of vehicles. The objects that you create might be cars, buses, trucks, or two-wheelers. Let's consider this with a visual example. There are different kinds of products that you might want to build. Products might be mobile phones or products might be laptops. So you have a product base class that encompasses the common characteristics of mobile phones and laptops, and then you have product 1 that might be mobile phones and product 2 that might be laptops. Now, you may not want your clients to be exposed to details of how mobile phones and laptop objects are constructed. So, you'll set up an interface which is part of your framework, which contains the factory method make product. This make product interface will simply take in as an input argument the type of product whose object you want to instantiate, and it will return a product object of the right kind. Now, you might have a number of different applications that require product objects in order to work with them. You'll have application 1, application 2, application 3, and so on. All of these applications, instead of constructing products themselves, whether mobile phones or laptops or any other kind of product, will simply use this make product factory method that we've exposed. Let's say application 1 needs objects of type mobile phones. Instead of constructing this object itself, it'll invoke the make product factory method and specify type equal to mobile phones. Similarly, if application 2 needs objects of type laptops, it'll specify type equal to laptop to the make product factory method. The factory method here will ensure that the right product object is instantiated for each of these applications and product 1, that is an instance of the object mobile phones, is returned to application 1, and product 2, an instance of the object laptops, is returned to application 2. The factory method takes in input arguments from the applications that invoke the method. It will then evaluate the arguments and decide which derived object to create and return to those applications. The factory method is closely related to the abstract factory pattern, and we often study them together, but they're actually different. Let's see how. Using the factory method, you'll create an instance of any one of many derived classes based on the input arguments that clients have passed into the method. With the abstract factory pattern, you're actually dealing with families of derived classes. And the abstract factory pattern allows you to create an instance of any one of many families of classes. So you may have families of classes. When you're dealing with vehicles, cars, trucks, and buses are different types of objects, but within cars, you might have different types of cars, such as sedans and convertibles and hatchbacks. A car may not be a derived type by itself, but can be considered to be a family of derived types, where the different derived types are the different types of cars. Under the hood, the abstract factory may use the factory method pattern that we discussed earlier. The aim of the abstract factory will be to encapsulate a group of individual factories that have a common goal. Let's consider an example here of the abstract factory so that it's clear what it represents and how it differs from the factory method that we spoke of earlier. The use case that we'll consider is that our team works with both Oracle databases as well as MS SQL databases. Now, each of these types of databases from different companies represents a family of classes or objects. There are different kinds of Oracle databases. Correspondingly, there are different flavors of MS SQL databases as well. So you have the abstract database factory, and this abstract database factory under the hood has a Microsoft factory capable of creating database connections to all Microsoft SQL databases. It will also work with the Oracle factory, which is capable of creating connections to Oracle databases, the whole family of them. Consider a hypothetical case when you're looking to move from one kind of database to another, let's say from an Oracle database to a Microsoft database or vice versa. If you set up your database code such that all of your connection creations use the abstract database factory, all our database flavors should work as is after we've switched over from one kind of database to another. Since all clients are instantiating their connection objects using this abstract database factory, they don't need to know what kind of database they're working with, provided the queries are compatible. Now, how do you make the choice of the factory pattern for your situation, for your use case? You'll use the factory pattern when object setup and creation has a high level of complexity. Let's say the object needs a bunch of configuration parameters that need to be specified correctly, and it's not easy to do so. You'll also use the factory pattern when you need to generate different instances of an object. The factory method allows your clients to specify the kind of object they're interested in, and the method will take care of creating and instantiating the right object for them. You'll also use the factory pattern when the objects that you're creating with this factory share common characteristics. You'll not use the factory method pattern when the objects are completely dissimilar or different from one another. Another reason you might use the factory pattern is when you want to decouple actual object creation from the API or the interface that you expose to your clients. Now, there are certain things that you need to watch out for when using the factory pattern. Remember, design patterns are not for free. There are certain things you need to manage when you use them. The factory pattern adds complexity to the creation of your objects because now they're gated through an additional interface. Now, if you're constructing objects directly, it's easy to unit test such code. These additional abstractions that the factory pattern and the abstract factory bring in might make unit testing difficult. After having explored all of the different ways in which objects can be constructed in JavaScript, let's move on to another creational design pattern, that is the factory pattern. All of the code for the factory pattern we'll write within the top level directory called factory pattern. Under this, we have an HTML file and a JS file. The factory pattern is a creational design pattern used to create objects in JavaScript. Now, the factory pattern does not expose the constructor of an object directly to the user. It abstracts away object creation details using a common interface. And this common interface is what users use to create different objects. The right object to be instantiated is determined by the code behind this interface based on what input arguments you've passed in. The HTML file for this factory design pattern is fairly straightforward. We have an H2 header which says factory pattern, and we have a script tag which references the JS file where we'll write our code, factorypattern.js. So all of the interesting details will be in this JS file, and that's where I'm going to head over. I'm going to use the factory design pattern to create objects which are of the base class type vehicle. So I'm first going to set up the base class first, and we'll have different types of vehicles that can be created, and the different types of vehicles all inherit from this base class. Because it's the most intuitive syntax, I'm going to use Es6 classes in order to set up my class structure or my object structure. Here is the base class called vehicle. Within that, I have the constructor method that will be used to construct this object. It takes in 3 input arguments: the vehicle type, the make, and the model of the vehicle. These then are assigned to properties of this object: this dot vehicle type, this dot make, and this dot model. In addition, the vehicle class has a number of functions, and as is the best practice recommended, I'm going to define these functions outside of the constructor so that they will be on this vehicle prototype, and these function objects will be shared across all vehicle objects that we create using this base class. The function that I've defined here is fairly simple. It simply is print details, and I've used the console log in order to print out this dot vehicle type, this dot make, and this dot model to console messages. I'm now going to set up 2 different object constructors which extend from this base vehicle class. The first is the class car that extends a vehicle, and within the constructor of this car, it takes in a single object called details, which contains the details of the car that we want to instantiate. Note that when you use the ES6 class syntax, you can specify an inheritance hierarchy for your objects. Any object of the class car will inherit from the base vehicle class that we set up earlier. Now, the details of the car include the make of the car and the model of the car. I use the super function within the constructor of this car class to invoke the constructor of the super class, that is the vehicle class. The vehicle type is car. I pass in details.make and details.model to the superclass constructor, and I assign the car type property also available in details to this dot car type. Within this derived class car that extends from the vehicle base class, I override the print details function. The only reason that I really have to override the print details function is that I want to print out the car type to the console log as well. So within this print details, I invoke super.printDetails, that is the same method on the super class, and then I also log out the car type. I'll now define another class which derives from the base vehicle class that we set up earlier. This class is called truck and will be used to instantiate trucks. Class truck extends vehicle, and within the constructor of this truck class, it takes in a single details object. I invoke the constructor of the superclass, that is the vehicle class, and pass in the vehicle type, which is truck, and I pass in the make and model of this truck, details.make and details.model. The details object here also contains the type of truck that we want to instantiate. I assign details.truckType to this .truck type. Once again, as I did earlier in the car class, I'm going to override the print details function. Observe that I have defined the print details function outside of the constructor so that it is a part of the truck prototype. This function object will be shared across all truck objects. Within the print details of this truck derived class, I invoke super.printDetails and print out to the console log this.truck type. Now that I have the individual classes for the vehicles defined, I'm now ready to set up a vehicle factory. And this vehicle factory will contain the interface that I'll use to instantiate the different vehicles. This vehicle factory has a single method here called create vehicle, which takes in the type of vehicle that we want to create and all of the additional details about that vehicle as a single details object. This create vehicle method within this vehicle factory class will take a look at the vehicle type that we want to create. By default, we'll create cars. So vehicle constructor by default is set to car. If the user specifies vehicle type equal to car, the vehicle constructor will be car. If vehicle type is equal to truck, the vehicle constructor will be the truck constructor. Once the factory has figured out which constructor to use for the vehicle, we'll simply instantiate a new object using that constructor. We return this new object to the user who has invoked this factory function to instantiate objects. This create vehicle is the factory method which hides all of the instantiation details of vehicles. Now that we've defined this factory class, all we have to do to use this factory design pattern is to instantiate an object of this vehicle factory, which we do using new vehicle factory. Now that we have a vehicle factory, let's first use console.log to view the contents of this vehicle factory object. Save your files and let's switch over to the Chrome browser and click through to factorypattern.html. Here is the code for the factory pattern, and if you open up Chrome Developer Tools, here is the vehicle factory object. I'm going to expand this object so that we can take a look at its contents. You can see that there are no properties on the vehicle factory itself, but if you expand this proto property, you'll be able to see the create vehicle function that we'll use to instantiate vehicle objects. And the constructor is the class vehicle factory, which was used to create this vehicle factory object. I'm now ready to go back to my code editor and use this vehicle factory to instantiate different kinds of vehicles. In order to first construct a car, I'm going to set up an object containing the details of the car that I want instantiated. The make is Honda, the model is Civic. Make and model are both characteristics or properties of vehicles. The car type here, which is a property specific to a car, is type sedan. Now, all a user has to do to create a car object using our vehicle factory is to pass in these car details to the create vehicle function. Vehicle factory.create vehicle, the type of vehicle that I want to create is car with the details in car details. Now that we've used the factory design pattern to create a car object and assigned it to the car variable, let's print out the contents of this object using console.log. We've created this car and let's call car instance of car to check whether this car object is indeed an instance of the car class. And we'll check for this using the instance of keyword in JavaScript. Save the changes that you've made to this file and let's head over to Chrome and hit refresh on our factory pattern page. And there you see in the console log are details of the car that we just created using the factory pattern. I'm going to expand this car object and take a look at its contents. You can see that vehicle type is set to car, the make is Honda, the model is Civic, and the car type is a sedan. And if you take a look at the proto here, you'll see the constructor that was used, which is the car class constructor. And you can see that the print details function is also available in the proto. If you remember, the proto property will give us information of what object was used to create this car object. And you can see that the proto property tells us that the vehicle base class is what was used to create this car object. You can also see here that the car object that we created is indeed an instance of the car constructor, car with a capital C. Let's head back to Sublime text here and I'm going to invoke the print details function on this car object. Make sure you save changes to this file and let's head over to the Chrome browser and hit refresh. And here we have the details of the car object that we just constructed using the factory pattern. The vehicle type is car, make is Honda, model Civic, and the car type is sedan. When we invoke the print details function on a car object, it invokes our overridden print details. When we invoke super.print details, that's what prints out the vehicle type, make, and model of this car. And the car type is something that we log out within the print details of the car class. We'll now go back to our code editor to see how this same vehicle factory can be used to construct a truck object. We'll first set up a details object for our truck, which contains the make of the truck, that is Ashok Leyland, the model D20B, and the truck type is a flatbed truck. These truck details we'll use to construct our truck object. Invoke the create vehicle function on our vehicle factory and pass in truck as the vehicle type that we want to construct. Based on the vehicle type that we have specified, truck, the vehicle factory will use the truck constructor, pass in the truck details, and create an instance of the truck class. We'll then print out to the console log the truck object and check to see whether the truck object that we have is indeed an instance of the truck class. Save the changes that we've made back to Chrome, hit refresh, and here at the bottom you can see all of the details of the truck object that we've created. You can see that the vehicle type here, when you expand the truck object, is truck, make Ashok Leyland, model D20B, and the truck type is a flatbed. If you take a look at the proto property of this truck object, you'll see a number of interesting details. You can see that this truck object was created using the vehicle object, which happens to be the base class of the truck. You can see the constructor that was used was the class truck constructor, and the print details method is also on the prototype of this object. And here at the bottom, we have the message which confirms to us that the truck object is indeed an instance of the truck class. All that we have to check here is that we can invoke the print details function on this truck object. Truck.printDetails, hit refresh on this page, and the details of the truck have been printed out to screen. We've seen how we can successfully set up the factory design pattern and use that to instantiate objects in JavaScript. Now that we have a basic understanding of how the factory design pattern works, we'll see a slightly different way to implement the same design pattern. The change is not great, but it's a little different, and I believe it ends up making your factory design a little more elegant. I'm going to go ahead and select all of the code starting from the vehicle factory class that we had set up earlier and get rid of that code. So what we are left with in this file here is the base vehicle class and the car and the truck classes that we had defined. Instead of a vehicle factory that can construct objects of all types of vehicles, I'm going to set up a custom vehicle factory that will construct either cars or trucks. And which type of vehicle it's able to construct, we'll specify as a part of the constructor. The constructor for this custom vehicle factory takes in the vehicle type. If the type of vehicle that we want to construct is a car, we'll set vehicle constructor to be the car constructor. If the vehicle type that we want to construct is a truck, we'll set vehicle constructor to be the truck constructor. We figured out what constructor we want to use in the constructor of this custom vehicle factory. So the create vehicle function for this factory simply uses the vehicle constructor initialized earlier, passes in the details object to that vehicle constructor to construct either a car or a truck. Now, if I want a factory that will construct different types of cars, I can instantiate the custom vehicle factory with vehicle type car. This is my car factory, and I'm going to log out the details of this car factory to the console. Save this file, head over to the browser and hit refresh, and let's take a look at our custom vehicle factory that is capable of constructing different types of cars. I'm going to expand this custom vehicle factory, and you can see the vehicle constructor there creates vehicles of type car. The vehicle constructor is the class car. If you expand the proto object for this custom vehicle factory, you'll see the create vehicle function which we'll use to create different types of cars. I'll now switch back to our code editor, and exactly like we have the car factory, I'm going to set up a custom vehicle factory that knows how to create truck objects. I instantiate the custom vehicle factory and pass in vehicle type equal to truck. If you're curious about the truck object and what it looks like, let's print it out to the console log and switch over to the browser window, hit refresh and explore this object. Along with the car factory, we now have a truck factory. and that is a custom vehicle factory as well. The truck factory is capable of constructing truck object. The vehicle constructor that it uses is the class truck. And if you expand the proto property of this truck factory, you'll see the create vehicle function that we'll use to create truck objects. Now let's head back to our code editor and let's create a new car. I'll first set up a JavaScript object to specify the details for the car that I want to construct. The make is BMW, the model is the 5 Series, and the car type is the convertible. Now, in order to create cars, I'll use the car factory. I invoke car factory.create vehicle, pass in the car details. I don't need to specify the vehicle type here because I'm already using the car factory. And once I have an object of the type car, I can print out the details of this object to the console log. I'll also check to see whether this object is an instance of the car class. I'll now head back to my Chrome browser and hit refresh, and in the console log, you'll see the details of the car object that we just created. If you expand this object, you'll see that the vehicle type is car, the make is a BMW, the model is the 5 Series, and the car type is a convertible. And if you take a look at the proto of this car object that we created, you'll see the constructor that was used was the class car, and the print details function is also available on the prototype. And the message at the bottom tells us that the car object that we have is indeed an instance of the car class. Back to our code editor, let's invoke the print details function on this car object, hit refresh, and there at the bottom we can see all of the details of the car object that we just created. Back to our code editor, where we'll now instantiate a truck using the truck factory that we had set up. The truck details tell us that the make of the truck is the Western Star, the model is the A1, and the truck type is a lowboy trailer. All we have to do to create a truck is to invoke truckFactory.createVehicle and pass in the truck details. We'll print out the resulting object to the console logs and check to see whether the object is an instance of the class truck. Back to the Chrome browser, where we'll hit refresh and see the result of the changes that we just made. You can see that a new truck object has been created here. And if you expand the object, you'll see the make, model, vehicle type, and the truck type that we had specified. If you expand the proto for this object, you'll see that the constructor that was used was the class truck, and we have the print details function also on the prototype. And we also have the message confirming to us that the object that we constructed is an instance of the truck class. Now back to our editor, where we'll invoke truck.print details and view the result of this print details function here within our browser. At the very bottom here, all of the details of the truck has been printed out to screen. In this video, we saw a slightly different implementation of the factory design pattern in JavaScript, and this leads us nicely onto the abstract factory implementation that we'll take a look at next. In this video, we'll see how we can implement the abstract factory design pattern in JavaScript. The abstract factory design pattern tries to bring together or encapsulate a group of factories which create objects that have a common goal. Thus, the abstract factory design pattern is closely related to the factory pattern in that it's used to create objects and abstract away details of creation from the user, but the abstract factory pattern is used to create families of objects, related objects that have similar characteristics. For example, we had the truck factory and the car factory earlier. Both of these factories together actually form a logical group used to create vehicles. And this is exactly what we'll try and capture using the abstract factory pattern. So here is the base class vehicle. There is no change from the vehicle base class that we saw in the earlier demo. The constructor of this vehicle class takes in a vehicle type, make, and a model and assigns it to the properties of this object. Every vehicle also has the print details function, which prints out the type, make, and model of this vehicle. In addition, I'll define two other functions that make up this vehicle's interface. Every vehicle has a drive function because all vehicles can be driven. The body of this drive function simply prints out a log message to the console. Every vehicle also has a fill fuel function which prints out fill fuel to the console. These just serve as examples of some functions that may make up your vehicle's interface. The next thing I'm going to set up here is a car class which derives from the vehicle base class. Class car extends vehicle. The code here is exactly the same as what we saw earlier. We have a constructor which takes in the details object. We call the superclass constructor, pass in vehicle type car, details.make and details.model. And we assign details.car type to this.car type. I also override the print details function from the vehicle's base class to log out the type of car that we've instantiated. Exactly like we did earlier, I'm going to have a class truck which extends the vehicle base class. The constructor simply passes in vehicle type as truck, the make, the model, and sets the value of the truck type property. I override the print details method from the base class and call super.printDetails and log out to the console the type of truck that we have instantiated. In addition to cars and trucks, I'm going to set up another class here which represents another type of vehicle, the two-wheeler, such as bikes and scooters. The class two-wheeler extends the vehicle base class and the constructor takes in a details object. It passes in vehicle type to the superclass constructor. The vehicle type here is two-wheeler and it also passes in details.make and details.model. In addition, we also have a two-wheeler type, whether it's a bicycle, a motorbike, or a scooter. These are examples of two-wheeler types, which is also assigned in the constructor. We also have the print details function that we override to print out the two-wheeler type. We'll set up now a vehicle factory class that will allow us to instantiate different types of vehicles, cars, trucks, or two-wheelers. The constructor of the vehicle factory takes in the vehicle type. The vehicle type we'll assume by default is a car, but we'll switch based on the vehicle type that the user has specified to use the right constructor. If the user says the vehicle type is a car, then we'll use the car class constructor. If vehicle type is truck, we'll use the truck class constructor. If vehicle type is two-wheeler, we'll use the two-wheeler constructor. By specifying the kind of vehicle that we want to create, we can use the same vehicle factory to construct cars, trucks, or two-wheelers. This vehicle factory also needs a function allowing us to create vehicles. This is the create function that takes as an input argument the details object and then simply invokes the new command on the vehicle constructor and passes in details. Based on what this factory is supposed to create, the right object will be constructed and created. For each of the different types of vehicles that I'm going to create, I'm going to set up a different factory that extends from this base vehicle factory. The class car factory extends vehicle factory, and within the constructor here, we simply specify the vehicle type is equal to car. That's all we need to do. This will ensure that the car factory uses the car constructor to instantiate car objects. Similarly, I'll set up a new class called truck factory which extends the base vehicle factory, and the constructor here simply calls the superclass constructor of the vehicle factory with vehicle type equal to truck. The base vehicle factory will ensure that this truck factory will be used to create just truck objects. And in the same way, I set up a two-wheeler factory as well. Two-wheeler factory extends vehicle factory and in the constructor calls the superclass constructor with vehicle type two-wheeler. The next step is to set up an abstract vehicle factory that will allow me to create cars, trucks, and two-wheelers using their corresponding factories. And here is what my abstract vehicle factory looks like. And I've chosen to implement this abstract factory using an immediately invoked function. An immediately invoked function in JavaScript is a function that is invoked as soon as it is defined. Immediately invoked functions are what you use to create modules in JavaScript. They are extremely useful because they help you avoid polluting the global namespace with variable instantiations and methods. Instead, you will access those methods and variables using the object that is returned by this immediately invoked function. When we are discussing JavaScript design patterns, you'll find that this immediately invoked function plays an important role. We'll work with this in more detail in the module pattern and the revealing module pattern. We have a variable definition here called abstract vehicle factory that holds the return value from this immediately invoked function. we know that this function is immediately invoked because it's defined within parentheses. The opening parenthesis on line 125 starts the function definition. We then have the function keyword, and the function definition is complete on line 132. The first closing parenthesis that you see there completes the function definition. Observe that immediately after that, we have an opening parenthesis and a closing parenthesis, and this is the function invocation. So the opening and closing parenthesis on line 132 indicates that as soon as this function is defined, we invoke it. This immediately invoked function is an anonymous function that is defined, immediately executed, and the object that it returns is stored in the abstract vehicle factory variable. All variables and methods that you define within this function are no longer in the global namespace of JavaScript. Within this function, I've defined a variable called factory types that is an object. This is the variable that we'll use to register the different factories that we'll use to construct different kinds of vehicles. The return value from this immediately invoked function is an object as specified by the curly brackets. Now, within this object, I'm going to define a function called getVehicle. GetVehicle is the function that our abstract vehicle factory exposes to the user. This function takes in two input arguments, the vehicle type and the details object. Once the abstract factory knows what type of vehicle it has to construct, it will then look up that corresponding vehicle factory in the factory types variable. If a vehicle factory corresponding to this vehicle type is found to have been previously registered, we'll then use this vehicle factory to create the kind of vehicle that the user expects by passing in the details object to vehicle factory.create. If no vehicle factory for that vehicle type has been previously registered, we'll simply return null from this getVehicle function. So it's pretty clear from this code here that vehicle factories to create cars, trucks, and two-wheelers have to be registered upfront before the abstract factory can use them. In order to allow vehicle factories to register themselves with this abstract factory, we'll expose another method here called register vehicle factory. This method takes in a vehicle type and the vehicle factory that needs to be registered. This method here does a bunch of basic checks to check whether the vehicle factory has a certain interface that this abstract factory expects. It'll first check to see whether the prototype of the vehicle factory contains a create function used to create vehicle objects. If the vehicle factory does not have a create function, it'll go ahead and throw an error indicating that a create method is expected on the factory. This method will then check to see whether the vehicle factory contains a vehicle constructor used to construct objects. If no vehicle constructor has been defined on this factory, this method will throw an error saying vehicle constructor expected on the factory. And finally, it will perform a check to see whether the vehicle constructor has the right interface. It will check to see whether the vehicle constructor prototype has a drive function and a fill fuel function, because these two functions make up the interface of a vehicle. If either of these functions are not found, this method will throw an error which says vehicles constructed should have a drive and fill fuel method. If all of these checks pass, this means that the vehicle factory has the correct interface as expected by this abstract factory, and the vehicle constructor also has the right interface. In that case, we'll go ahead and register this vehicle factory and assign it to the factory types object indexed by the vehicle type. Once this vehicle factory has been registered, that is, it has been assigned to the factory types object, this factory can be used to construct vehicles, whether it's cars, two-wheelers, or trucks. Now that we've set up this abstract vehicle factory, let's go ahead and register the different factories used for constructing different kinds of vehicles. We can call abstract vehicle factory dot register vehicle factory and register a new car factory that we'll use to create car instances. In exactly the same way, we'll use the register vehicle factory function on the abstract vehicle factory to register the truck factory as well. Now, observe that I haven't registered the two-wheeler factory yet. I'll do that a little bit later, but before that, let's print out the contents of this object to the console log and take a look. switch over to your Chrome browser and click through to abstractfactorypattern.html and open up Chrome Developer Tools. You can see the abstract vehicle factory object has been printed out to screen. Expand this object to view its contents. You see that it exposes two methods, get vehicle and register vehicle factory. The factory types variable that we use to store vehicle factories is not publicly exposed because it was declared inside the immediately invoked function. But both of these functions here, get vehicle as well as register vehicle factory, can access the factory types variable because it is a part of their closure. Let's take a look at what I mean here. If you expand the get vehicle function, you can see a property here called scopes. The scopes tell you what scopes this particular function can access. If you expand this, you'll see that this function can access the global scope, that is the parent window object. It can also access the script scope, that is, it can access all of these classes that are defined within your JS file, the vehicle class, the car class, the truck, the two-wheeler, the vehicle factory, and so on. But the first scope here is the most interesting, and you can see that this is the closure scope. Get vehicle can access the variables declared within its closure, and that is the factory types variable. Since this is an advanced JavaScript course, hopefully you already know what closures mean in JavaScript. If you don't remember, here is a quick one-line definition. A closure in JavaScript gives you access to variables in the outer function from the inner function. Get vehicle here is the inner function, and the factory types variable that has been declared in the outer function, the immediately invoked function, and the inner function has access to this variable declared in the outer function. This factory types variable is a part of the method's closure, and it's not available in the global scope or in the script scope, only within the closure. If you close this get vehicle function details and expand the details for register vehicle factory, you'll see something similar. You'll see that there are three scopes associated with register vehicle factory, and if you expand the scopes, you'll see that we have the closure scope, the script scope, and the global scope. The closure of this register vehicle factory function includes the factory types variable where the factories are registered and can be accessed. Now that we have set up our abstract vehicle factory following the abstract factory pattern, let's go ahead and use it. I want to use this factory to create a car. So I set up a car details object. The make of the car is a BMW, the model is the 5 Series, and the car type is a convertible. In order to construct a car using our abstract factory, all we have to do is invoke the get vehicle function on the abstract vehicle factory. We pass in the vehicle type, that is car, and pass in the car details as well. The abstract vehicle factory get vehicle will first check to see whether a car factory has been registered for building cars. And if yes, it'll go ahead and construct a car using that factory. The constructed car object is now available in the car variable, and we can print out to the console log this car object and check to see whether it's an instance of the car class. Make sure you save the changes that you made to this file, and let's switch over to Chrome and hit refresh, and you'll be able to see the car object that we constructed using the abstract vehicle factory. You can expand this car object. You can see the vehicle type is car, make BMW model 5 series, and the car type is a convertible. And you can see that this object is also an instance of the car class. If you see the proto property of the car class, you can see that it extends the vehicle class. It has the print details function, and you can see that the vehicle class has the drive and the fill fuel methods as a part of its interface. The car object has been constructed successfully. We can go back to our code editor and invoke the print details function on this car object, hit refresh on our browser, and see the details of our car printed out to screen. I'm now going to head back to the code editor and use this abstract vehicle factory to construct a truck. Here are the details of the truck. Make is Western Star, model is A1, and the truck type is a lowboy trailer. Call the get vehicle function on the abstract vehicle factory, pass in the vehicle type as truck, and pass in the truck details. We have previously registered the truck factory used to create trucks, which means a truck object will be successfully constructed. We can print out the details of this object and check to see if it's an instance of the truck class. Let's switch back to Chrome and hit refresh, and you can see the details of the created truck printed out to screen. You can then expand this truck object and satisfy yourself that the details of the truck are exactly what you specified when you created this truck object. You can see that this object is an instance of the truck class as well. Back to our code editor, we can now invoke the print details function on the truck. Now, what I'm really interested in is constructing a two-wheeler, so I'm going to go on to that bit of code. Here are the details of my two-wheeler. The make is Hero, the model is Z23, and two-wheeler type is a motorbike. I'm going to now use the abstract vehicle factory get vehicle method in order to construct this two-wheeler. But there is going to be a problem here. That's because I haven't previously registered the two-wheeler factory with my abstract factory. Any factory has to be previously registered for it to be used in order to construct objects. So I'll print out the two-wheeler object and check to see if it's an instance of two-wheeler here. But when we switch over to the Chrome browser and hit refresh, you'll notice that no two-wheeler was created. The two-wheeler created was just null. The way we've set up our abstract vehicle factory, we need to register the factory that it's able to use to construct objects. So let's go ahead and register our two-wheeler factory by invoking the register vehicle factory function, specifying the vehicle type as two-wheeler, and setting up a new two-wheeler factory. Once this is done, we can call abstract vehicle factory.get vehicle to construct different types of two-wheelers. Pass in the two-wheeler details, and let's print out to our console log the two-wheeler object that was created and check to see whether it's an instance of the class two-wheeler. We'll head back to our Chrome browser here and hit refresh, and here at the bottom of our console messages, you can see that we have successfully managed to create a two-wheeler object after registering the factory. If you expand the two-wheeler object, you can see the vehicle type is a two-wheeler, make is Hero, the model is Z23, and the two-wheeler type is a motorbike. Once the two-wheeler factory was registered, our abstract vehicle factory successfully constructed a two-wheeler object. We can invoke the print details function on the two-wheeler, hit refresh, and all of the details of the two-wheeler will be printed out to screen. In this course, we commenced an exploration of common creational patterns in JavaScript, specifically the use of the constructor pattern to create and initialize objects, including the object literal notation, assigning properties and functions, and using functions as well as Es6 classes to construct objects. We've also covered both the factory and abstract factory to create different kinds of objects. In addition, we also covered the implementation details of these patterns as well as the use of immediately invoked functions for the abstract factory pattern implementation. At this point, you possess the knowledge needed to correctly enumerate several of the most important creational design patterns, apply those patterns to a JavaScript context, identify situations where each type of pattern is appropriate, and thus implement the constructor, factory, and abstract factory creational design patterns. You are now set up to explore other creational design patterns in detail, such as the singleton, prototype, and builder design patterns.